When I was talking about basic curves and what have you, I was saying that all of them could be created by translating, shifting, that sort of thing. So that's what we're now going to look at, translating curves. How do we recognize the shift? Well, a horizontal shift is when we replace the x in the function with an x minus h, so it's grouped with the x. So you see something like this. Instead of y equals function x, it's essentially y equals function x minus h. Now if you see that, you know it's moved left or right depending on whether it's negative or positive. Okay? If you're unsure how it's been shifted, then simply solve that grouping, x minus h. Whatever solves that, which would be x equals h, will tell you where the origin of just function x has been moved to for the new curve. Vertical is very much the same, except it's grouped with the y rather than with the x. So you'd see something like this. Well, in reality, you probably don't see something like this. You more often see it like that, where that k is moved to the right-hand side. But in reality, it's a grouping with the y, just like the other one was a grouping with the x. But that'll tell you how much it's shifted up or down. And if you're unsure, again, you could solve y minus k in this case is equal to 0. It's all right. Let's look at something. We've been talking about parabolas. Now we know what this looks like already because we talked about the completing of the square, how it would identify where the vertex is straight away. But how would we get that same picture using this idea? So the basic curve, well, it's a quadratic. It's y equals x squared. That was the basic parabola. So what have we done to it? Well, the first thing I noticed, grouped with the x, we have a horizontal shift. It's shifted right 3, because what solves x minus 3 equals 0? It would be x equals 3. So where the origin is right now, that would get moved across to 3. But there's another shift happening, the plus 4 there. So basically we're shifting it up 4. Now using that grouping idea, remember that 4 really would be on the other side. We'd have y minus 4. What makes that equal to 0? Well, plus 4 does. So we'll shift it up 4. And there's the parabola now shifted into position. Its vertex is at 3, 4. But we can use that with anything. This one here is a circle. I recognize it to be a circle because x squared and y squared, the coefficient is the same. So I know it's a circle. But I've got to do some completing of the square to see what's happening here. So I've got to do it on both the x and the y. So I'll end up with x plus 1 squared plus y minus 2 squared is equal to 9. So what does that look like? Well, the basic curve is when I've got to circle out the origin. So x squared plus y squared is radius squared, which in this case is 9, so the radius is 3. I probably should have marked 3 on my axes, but anyway. What have we done to it? Well, grouped with the x, I've got a horizontal shift. That would mean the centre there, so the origin, has moved left. So it's over there, but moved left. And we've also got a grouping with the y, so I've moved up. So there's my new circle. Centre minus 1, 2, radius 3. Again, I probably should have written the radius down there to give it some sense of scale. But there's our picture. Y equals 2x squared plus 8x plus 5. Well, I'm going to have to complete the square here. But I've turned it into a monic because I find completing the square easier when it's just x squared, not 2x squared. Now I can do it. Well, it's x plus 2 all squared, work out my constant. Let's multiply everything by 2, get it back to y equals. So I've rearranged the equation to be y equals 2 outside x plus 2 squared minus 3. So what is happening with this one? The basic curve is x squared. The 2 out the front, we haven't really talked about that. We'll talk about more later, but essentially that's going to make it a steeper curve. Same as y equals 2x is steeper than y equals x. Same deal. So the curve gets steeper. So I'll just make it a little bit steeper. Now I can see I've got a horizontal shift. I'm going to move it to the left 2 units. And I'm going to move this one down 3 units. And so that'd be my parabola. So that's the idea of translating. So moving up or down, left or right. Reflecting curves. A vertical reflection. So that's when we replace x with negative x. So we'd see function negative x. That would reflect in the y-axis or vertical. Now interestingly, you don't have to reflect in the y-axis. You could reflect in any line you like. You could reflect in the line x equals a if you replace x with 2a minus x. So when it was reflecting in the axis, a was 0, so you just got negative x. But in reality, this is how you reflected any line, and let me show you why. Here's y equals function x. If I reflected it in the y-axis, I get function negative x. So that would be the red curve. But if I put a horizontal shift on of 2a, then if you compare my final curve there with the original curve, you can see it's a reflection in the line x equals a. And you can do a similar thing horizontally. If you replace y with negative y, so negative y equals function x, although you're probably more likely to see it written that way, y equals negative function x. It all comes down to what it's grouped with. If it's grouped with the y value, then it's the y values that are affected. If it's grouped with the x values, it's the x values that are affected. And similarly, if I wanted to reflect it in any other line, I'd replace y with 2a minus y. And let's do that one. There's function x. Reflect it in the x-axis, it would become minus function x. But then I do a vertical shift of 2a. Now have a look at my final curve and my original curve, and that's reflected in y equals a. Reflection in the origin, both of them become negative. So y equals negative function negative x. What it basically is a rotation of 180 degrees. It ends up being a rotation of 180 degrees. Right? So it's two reflections, one in the x-axis, one in the y-axis, and you end up with this rotation. Let me show you. Here's random curve y equals function x. If I first of all reflect in the x-axis, so that becomes y equals negative function x. Now if I reflect in the y-axis, so it becomes negative function negative x, have a look at the first picture, have a look at the last picture. You can see we've rotated that curve 180 degrees. A rotation of 180 is another way of saying reflection in the origin. So let's draw this one. Y equals negative x plus 1 cubed plus 2. So it's a cubic. Yes, a very dodgy cubic I've drawn there, but there's a cubic. What have we done to it? I've reflected it in the x-axis, because the negative's not grouped with the x, it's technically grouped with the y if I was to move it to the other side there. So alright, I'll reflect it. Now we've shifted it, and we've shifted it left 1 unit, but we've also shifted it up 2 units. So that would be my picture. It would go there. Y equals minus 2 to the power of minus x. Well, here's the one where both have been made negative. This is the one that's rotation. So there's the basic curve, 2 to the power of x. We're reflecting in the original, rotating 180 degrees. So spin it round and you'd end up like that.